The Bugatti Veyron Super Sport. Bugatti introduced the Super Sport in 2010 as the highest performance variant of the Veyron program. The quad-turbocharged 8.0-liter W16 produced 1,200 horsepower, an increase of 200 horsepower over the standard car, achieved through larger turbochargers and revised engine management. The top speed was 267.8 miles per hour, a figure verified by Guinness World Records on a closed section of Volkswagen's test track in Saleen. The tires fitted to the Super Sport were developed specifically for it by Michelin. No existing production tire could withstand the thermal and structural loads generated at 267 miles per hour. Michelin's development program for the Supersport tires took 2 years. The finished product had a speed rating that no road tire before it had carried. Bugatti imposed a 258-mile-per-hour electronic speed limiter on customer cars. The limiter existed not because the engine could not reach higher speeds, but because the tires on customer specification cars were not the same tires fitted to the record car. Michelin advised Bugatti that the standard delivery tires were not rated for unrestricted operation. Every Supersport delivered to a customer was therefore electronically prevented from reaching the speed it was mechanically capable of by the limitations of the rubber it rode on. The Koenigsegg Agera RS. Koenigsegg built 25 of them between 2015 and 2018. The twin-turbocharged 5.0-liter V8 produced between 1,160 and 1,341 horsepower, depending on the fuel used. On a closed Nevada highway in November 2017, a single Agera RS set 8 world speed records in one day. The two-way average top speed was 277.9 miles per hour. The tires fitted to the record car were Michelin Pilot Sport Cup 2 in a size that Michelin produced exclusively for Koenigsegg. Standard Pilot Sport Cup 2 tires in commercially available sizes are not rated for the speeds the Agera RS is capable of reaching. Koenigsegg worked with Michelin for 3 years to develop a construction capable of surviving the centrifugal forces generated at the car's limits. At 278 miles per hour, each tire rotates approximately 50 times per second. The centrifugal force attempting to separate the tire from its structure at that speed is equivalent to a sustained load of several tons applied outward from the center. The tires fitted to customer cars without the specific Michelin development program are not rated for unrestricted use at the car's maximum capability. The Bugatti Chiron Super Sport 300 Plus. Bugatti reached 304.773 miles per hour in August 2019 on the Saleen test track with a pre-production version of the Chiron Super Sport 300 Plus, driven by Andy Wallace. The quad-turbocharged 8.0-liter W16 produced 1,578 horsepower in the record configuration. The tires were Michelin Pilot Sport Cup 2 in a construction developed specifically for this attempt over a period Michelin declined to specify publicly. The customer version of the Chiron Super Sport 300 Plus was electronically limited to 273 miles per hour. The limitation was not engine-related. Bugatti stated directly that the decision was tire-related. The tires on customer cars had not undergone the same validation program as the record car's tires, and Bugatti would not permit customers to operate the car beyond the speed at which the standard delivery tires had been certified. The production run was 30 cars. Each sold for approximately 3.5 million euros. Every buyer received a car electronically prevented from reaching the speed that had made it commercially desirable by a tire certification boundary. The MF1. Gordon Murray completed the McLaren F1 in 1992 after 5 years of development. The naturally aspirated 6.1-liter BMW S70 V12 produced 627 horsepower in a car weighing 1,138 kilograms. In 1998, a standard road specification F1 reached 240.1 miles per hour at RS, a speed that remained the record for a naturally aspirated road car for over 2 decades. The tires were Michelin MMX3 in sizes developed specifically for the F1. No existing Michelin tire at the time of the F1's development was suitable for the car's performance envelope. Michelin worked with Murray from the earliest design stages to produce a tire that could function at the F1's limits. The MMX3 was the result. When those tires reached the end of their production life and Michelin ceased manufacturing them, the owners of the 106 road cars faced a supply problem that no other tire could solve. Michelin eventually agreed to produce a limited batch of replacement tires for existing F1 owners. The alternative was a fleet of cars that could not be used because the specific rubber they required no longer existed. The Enzo. Ferrari built 399 of them between 2002 and 2004, with one additional example constructed after the production run to replace a car destroyed in an accident. The naturally aspirated 6.0-liter V12 produced 660 horsepower, and the carbon fiber body incorporated Formula One-derived aerodynamic elements, including a diffuser and front splitter developed in Ferrari's wind tunnel. The tires were Bridgestone Potenza S04 in sizes and constructions developed in collaboration with Ferrari for the Enzo specifically. Bridgestone's development work for the Enzo tire ran parallel to the car's engineering program. The finished product carried speed and load ratings that required a new classification category. When Bridgestone subsequently restructured its high-performance tire range and discontinued certain constructions, the replacement options for Enzo owners narrowed significantly. The specific combination of size, construction, and compound that the Enzo's suspension and aerodynamic geometry had been calibrated around was not available from any other manufacturer. Ferrari worked with Bridgestone to ensure continued supply for existing owners, but the dependency the car had created on a single manufacturer's specific product illustrated the degree to which the Enzo had exceeded the boundaries of conventional tire engineering at the time of its development. The Porsche Carrera GT. Porsche built 1,270 of them between 2004 and 2006. The naturally aspirated 5.7-liter V10 produced 612 horsepower and was derived from a Le Mans racing program that had been cancelled before reaching competition. The carbon fiber monocoque and chemical composite clutch gave the car a character that demanded significant driver skill. The tires were Michelin Pilot Sport PS2 in sizes exclusive to the Carrera GT. The rear tire was 335 mm wide, a dimension that required a wheel width no standard production tire of the era was built to accommodate. Michelin produced the Carrera GT tires as a dedicated program. When that program ended and those specific constructions were discontinued, owners faced limited options. The geometry of the Carrera GT's rear suspension and the aerodynamic balance the car had been engineered around were calibrated specifically for those tire dimensions and constructions. Fitting alternatives required acceptance of handling characteristics that differed meaningfully from the car's original engineering intent. Several specialist tire manufacturers subsequently produced compatible alternatives. The transition period during which no direct replacement existed lasted several years and affected the usability of cars in private ownership during that time.
The Lamborghini Murcielago LP670-4 Super Veloce. Lamborghini built 186 of them in 2009 and 2010. The 6.5-liter naturally aspirated V12 produced 670 horsepower, the highest output of any Murcielago variant. Weight was reduced by 100 kilograms from the standard LP640 through carbon fiber body components and deleted interior equipment. The tires were Pirelli P0 Corsa in a rear size of 335 mm. Pirelli developed the P0 Corsa in close collaboration with Lamborghini across multiple models, but the Super Veloce specification required a compound and construction that sat at the boundary of what road tire certification permitted. The compound was soft enough to generate the lateral grip the car's aerodynamic and mechanical configuration demanded, but wore at a rate that many owners found incompatible with road use. Pirelli's recommendation for the Super Veloce tire in road driving conditions was a replacement interval significantly shorter than any other tire on any car in the same price category. The tire was engineered for the car's performance limits. Those limits had been set beyond the point where a road tire could simultaneously deliver grip and longevity. The Pagani Zonda F. Pagani built the Zonda F between 2005 and 2009 across roadster and coupe variants. The naturally aspirated 7.3-liter AMG V12 produced 602 horsepower in the standard configuration and 650 horsepower in the Club Sport variant. The tires were Pirelli P0 Corsa, in sizes developed with Pagani specifically for the Zonda F's weight distribution and aerodynamic balance. The rear contact patch was calibrated around a compound that Pirelli produced in limited batches. When Pirelli updated its P0 Corsa range and revised the compound specification, the handling balance of Zonda F examples fitted with the updated tires differed from cars fitted with the original production tires. The difference was documented by owners who drove the same car on both specifications. Pagani communicated the issue to affected owners and worked with Pirelli to identify the closest available alternative. The underlying problem was that the car had been engineered to a tire specification tight enough that a compound revision within the same tire model produced a measurable change in vehicle behavior. The tolerance between acceptable and unacceptable performance was narrower than the variation Pirelli's normal product development cycle introduced. The SSC Tuatara. SSC North America built the Tuatara as the successor to the Ultimate Aero, which had briefly held the production car top speed record in 2007. The twin-turbocharged 5.9-liter V8 produced 1,750 horsepower on E85 fuel. In October 2020, SSC claimed a top speed of 331 miles per hour during a run on a closed Nevada highway. The claim was subsequently disputed on technical grounds relating to the GPS data and the video footage. SSC conducted a second verified attempt in January 2021, achieving a two-way average of 282.9 miles per hour. The tires were Michelin Pilot Sport Cup 2R, in a specification developed with SSC for the record attempt. Michelin's involvement in the program included structural validation testing at speeds that required the company to develop new testing procedures. The tires used on the record run were not the tires supplied with customer cars. Customer delivery specification tires were rated to a lower speed threshold than the record attempt tires. SSC confirmed this distinction. The car delivered to buyers was electronically limited to a speed below the tire's customer specification rating. The record had been set on tires buyers could not purchase through standard supply channels. The Hennessey Venom GT. Hennessey Performance built 13 of them between 2011 and 2017 on a modified Lotus Exige platform. The twin-turbocharged 7.0-liter V8 produced 1,244 horsepower in a car weighing 1,244 kilograms, a power-to-weight ratio Hennessey stated was the highest of any production car at the time. In February 2014, a Venom GT reached 270.49 miles per hour at the Kennedy Space Center's shuttle landing facility on a closed runway. The run was conducted in one direction only, a condition that disqualified it from official production car top speed recognition under Guinness rules, which require a two-way average. The tires were Michelin Pilot Sport Cup 2R, in a specification developed with SSC for the record attempt. The 34.5mm rear tire required a wheel specification that Michelin did not produce for any other application. At the speeds the Venom GT was capable of reaching, the centrifugal loads on the tire structure exceeded the design parameters of any commercially available road tire.
Michelin's development work for the Venom GT tires was conducted under an agreement that did not extend to public retail supply. Replacement tires for existing Venom GT owners required direct contact with Michelin's specialist vehicle program. The number of Venom GTs built was small enough that Michelin's standard distribution infrastructure had no commercial basis for stocking the specific sizes and constructions the car required. The Mercedes SLR McLaren. Mercedes and McLaren jointly developed the SLR between 1999 and 2003. The supercharged 5.4-liter V8 produced 617 horsepower, and the carbon fiber body incorporated an air brake that deployed automatically under heavy deceleration. 2,157 were built between 2003 and 2009 across multiple variants. The tires were Michelin Pilot Sport PS2 in a rear size of 295 millimeters. The SLR's weight of 1,768 kilograms, combined with its power output, created thermal demands on the rear tires under hard acceleration that Michelin addressed through a specific compound formulation. The compound ran hotter than standard PS2 tires and required a warm-up period before delivering full lateral grip. Owners who drove the SLR in cold conditions without allowing the tires to reach operating temperature experienced handling behavior that differed significantly from the car's performance in optimal conditions. Mercedes issued guidance on tire operating temperatures as part of the owner documentation. The guidance acknowledged that the car's performance capabilities exceeded the operating window within which the tires delivered their designed performance characteristics consistently. The Saleen 7 Twin Turbo. Saleen built the 7 Twin Turbo between 2005 and 2008 with the twin-turbocharged 7.0-liter V8 producing 750 horsepower in a car weighing 1,260 kilograms. The mid-engined carbon fiber body generated 1,600 pounds of downforce at 160 miles per hour. The tires were Michelin Pilot Sport PS2 in sizes that Michelin supplied exclusively to Saleen for the S7 program. The downforce the car generated at high speed pressed the tires into the road surface with forces that increased with speed, a characteristic that improved high-speed grip but created thermal loading conditions that standard road tires of the era were not designed to manage. Michelin's development work for the S7 twin-turbo tires included high-speed durability testing at the company's Ladue facility in France. The finished product was a tire that performed within acceptable parameters at the S7's limits, but that Michelin declined to offer through standard retail channels. Replacement supply for S7 owners required direct contact with Michelin's specialist vehicle program. The number of S7 twin turbos built was small enough that Michelin's standard distribution infrastructure had no commercial basis for stocking the specific sizes and constructions the car required.